Ladies and gentlemen, I just thought that today we'd go through and do a friction review problem before we start the worksheet, because I thought that would be helpful for you. So what we're going to start out with is, Bobby, if you could read the review problem for me, that'd be great.
"Oh no," cried the roll of tape. "I'm sliding toward that evil basin full of belligerent Bossa Nova bandits. Will anyone save me?" "I can't do it," cried Captain Underpants. If the 52.4 gram roll of tape is sliding at 3.0 meters per second when the captain starts pushing on the roll at an angle of 15 degrees below the horizontal with a force of 0.2 newtons, and the mu k is 0.17 between the roll of tape and the table, will Captain Underpants succeed in his attempt to save the roll of tape from the basin of belligerent Bossa Nova bandits?
Bobby, let's see if we can give it a little more feeling on that one. Why don't you give it another try?
"Oh no!" cried the roll of tape. "I'm sliding toward that evil basin full of belligerent Bossa Nova bandits. Will anyone save me?" "I can do it," cried Captain Underpants. If the 52.4 gram roll of tape is sliding at 3.0 meters per second when the captain starts pushing on the roll at an angle of 15 degrees below the horizontal with a force of 0.2 newtons, and the mu k equals 0.17 between the roll of tape and the table, will Captain Underpants succeed in his attempt to save the roll of tape from the basin of belligerent Bossa Nova bandits?
Good. Billy, what are the givens? What do we know? The mass is 52.4 grams, but that's actually, we need kilograms for that, so it's 0.0524 kilograms. The initial velocity is 3.0 meters per second. The displacement is 75 centimeters, but that's really, we don't know that displacement, that's just something we're going to compare our displacement to in the end. The mu k is 0.17, and the force applied is 0.20 newtons at 15 degrees below the horizontal. All right, Bo, where do you want to start?
We should start with the force normal up. Force of gravity is always down. Force applied you gave us is going to be to the right and below the positive x-axis by 15 degrees. And the force of kinetic friction is to the left. Isn't the force of friction to the right because the object's moving to the left?
Yep, actually remember, the force of friction always opposes motion. It does not always necessarily in the opposite direction as the force applied, but it always opposes motion. From here, Billy, we need to break the force applied into its components because it's not in the x or the y direction. So the sine of 15 degrees equals the force applied in the y direction divided by the force applied. Bring the force applied over to the other side, we end up with force applied in the y direction equals the force applied times the sine of 15 degrees. So 0.2 times the sine of 15 degrees, and the force applied in the y direction ends up equaling 0.0518 newtons. And we can also do that with cosine. The cosine of 15 degrees is equal to force applied in the x direction divided by the force applied. So the force applied in the x direction equals the force applied times the cosine of 15 degrees. So 0.2 times cosine of 15 degrees equals 0.193 newtons. Janique? Noah? Correct. Remember, we should always redraw the free body diagram for clarity's sake so that we can see exactly what we're supposed to do. So, redraw the free body diagram. You can see force normal's up, force kinetic friction still to the right, force applied in the x direction is to the right, force applied in the y direction is down, and the force of gravity is down as well. You're going to have to sum the forces in the y direction. So force normal is up, so it's positive, minus the force of gravity because it's down, minus the force applied in the y direction. That whole thing equals mass times the acceleration in the y direction, but the roll of tape isn't moving up or down, so the acceleration in the y direction is 0. So force normal minus the force of gravity minus the force of acceleration. The force applied in the y direction equals 0. So force normal minus mass times gravity, because force of gravity is equal to mass times gravity. So force normal minus the mass times gravity minus the force applied in the y direction equals 0. So we have the values for the mass, g, and the force applied in the y direction. So force normal minus 0.0524 times 9.8 minus force applied in the y direction, which is 0.0518 equals 0. So we end up with force normal equals a number. We've just got that. That's force normal equals 0.5653 newtons.
Billy?
We need to sum the forces in the x direction. So summing the forces in the x direction equals force of kinetic friction plus the force applied in the x direction. Both are positive, which is equal to the mass times the acceleration in the x direction. The force of kinetic friction, the equation for force of kinetic friction is mu k times the force normal. So we can plug that in for the force of kinetic friction. We end up with mu k times the force normal plus the force applied in the x direction equals mass times acceleration in the x direction. We know everything in that equation except for the acceleration in the x direction. We want to solve for that. So 0.17 times 0.5653 plus 0.193 is equal to 0.0524 times the acceleration in the x direction. And so the acceleration in the x direction is going to be equal to 0.17 times 0.5653 plus 0.193, all of that divided by 0.0524. And that gives us an acceleration in the x direction of 5.52 meters per second squared. Now, we should all be able to see that what we have to do from here is to use our UAM equations. Shouldn't the initial velocity be negative because the roll of tape is moving to the left when we start? Actually, Bob, you are absolutely correct. The initial velocity should be negative because we are moving to the left. Good. Again, we just use the UAM equation, v final in the x direction squared equals v initial in the x direction squared plus 2 times the acceleration in the x direction times the displacement in the x direction. So we end up with 0 squared, which is just 0, duh, equals 3 squared plus 2 times 5.52 times the displacement in the x direction. So 3 squared is 9. You have to bring that over to the other side. That makes it negative. So we end up with displacement in the x direction is equal to 0 minus 9 divided by the quantity 2 times 5.52. It gives us a negative 0.82 meters. So the answer we get is the negative 0.82 meters or negative 82 centimeters. Because it is to the left, negative because it is to the left, just as Bo pointed out. So what do you think? Does the captain save the roll of tape? No! Because they slide further than 75 centimeters. They go 82 centimeters. No! No!